Welcome all. In this lecture, we are going to deal with one more example on Routh-Hurwitz criteria. The open loop transfer function of unity feedback system is given as g of s into h of s is equals to k e to the power minus s over s square plus 2s plus 1. So here the unity feedback is there. So h of s is equals to 1 and the open loop transfer function is given in the question. What we need to do is we need to discuss the stability of the closed loop transfer function in terms of k parameter. Okay, so let's discuss a fact that is we can write e to the power minus s as 1 minus s plus s square and so on. This is infinite, so it is keep on going, but by the help of linear approximation method, we can say that e to the power s is generally equals to 1 minus s only, because the further terms are so small, so we can neglect it easily. Here in this question, g of s into h of s is given by the expression, so we will simply put e to the power minus s in this expression. So g of s into h of s is equals to k 1 minus s over s square plus 2s plus 1. This is the product of g of s into h of s. Here h of s, since h of s is equals to 1 because the unity feedback is given in the question, that's why h of s is equals to 1. We all know that characteristic equation is represented as 1 plus g of s into h of s is equals to 0. Simply putting on the values, we will get 1 plus g of s into h of s will be equals to k 1 minus s over s square plus 2s plus 1 equals to 0. Further, on solving, we will get, on taking the LCM, as s square plus 2s plus 1 plus k 1 minus s is equals to 0. On multiplying it s in the bracket, we will get s cube plus 2s square plus s plus k minus ks is equals to 0. On taking the power of s common, we will get s cube plus 2s square plus 1 minus k s plus k equals to 0. So this is our characteristic equation. This is our final characteristic equation. On the basis of this characteristic equation, we will form the Routh array to check that the system is stable or not. So this is our characteristic equation on the basis of which we will perform and form the Routh array. So in this characteristic equation, let's separate the even and odd coefficient of s powers. So here the odd power of s here the odd power of s. So the odd coefficient are 1 of s cube and 1 minus k of s, and it is the even power of s, so the coefficient is 2 and the coefficient of s to the power 0 is k. Now let's form a Routh array. So highest power of s is s cube, so we will write s cube on the top. After that s square, then we will write s, then after we write s to the power 0. Since the highest power is s cube, so we will write the coefficient of odd power of s first. So here the coefficient of odd power of s is 1 and 1 minus k, that is 1 minus k. Now s to the power 2 is an even power of s, so we will write the even coefficient of s powers, that is 2 and k. Now we fill all the entries by the help of cross multiplication method. So 2 will be multiplied with 1 minus k, 2 into 1 minus k subtracted by k multiplied with 1, that is k only. The whole term will be divided with 2. So we get 2 1 minus k divided by 2. No column for the further multiplication, so we write 0 simply. After that, this term will be multiplied with k, so k 2 1 minus k divided by 2, and 0 will be multiplied with 2, so we will get 0. After that, this term will be divided, so 2 1 minus k divided by 2. This term will be cancelled out easily and we will get k as output. So k as output. No term for the further multiplication, so we will write 0 only. So here our Routh array is completed now, and for checking its stability we have to check the number of sign changes. Since for the system to be stable, the same sign should be there in the first column of a Routh array. So here is the first column of a Routh array, and the first digit is 1 and the second digit is 2. So both are the positive. So for the system to be stable, each and every element of a first row should be positive. So this term and this k value should be positive, that is greater than 0. So here are the two conclusions, that is this 2 1 minus k over 2 should be greater than 0, and k should be greater than 0. This k should be greater than 0. From this expression we can also say that 2 minus 2k minus k should be greater than 0 when opening the bracket, and k greater than 0. We can also say that 2 minus 3k should be greater than 0, or k 2 by 3 should be greater than k. This is the first conclusion and this is the second conclusion. So on combining both these conclusions, we will get the combined result of the k, combined range of the k as 0 is less than k is less than 2 by 3. This is the range of the k for which the system will behave as a stable system. Thank you. If you like my videos, then press the like button and subscribe to my YouTube channel.